then my phone rings.
What's that?
Yeah, we're recording. We're good to
Okay.
go.
I'd like to call this meeting a special select board meeting to order on May 5th, May 12th at 4 o'clock. Additions and deletions.
I would like to add two, if the select board would allow it, after the presentation. We'll vote on a liquor license for 506 on the river. And then, approval of a permit to move light fixtures from Green Mountain Power,
Light poles.
light pole, sorry.
Citizens' comments?
I'm seeing none online.
Seeing none. And again, presentation by Hoyle Cannon on the main wastewater treatment.
I think we're gonna turn the lights off. So I'm gonna read off of this. You guys can. All right, so let me just give a quick background. We're here to talk about, this is kind of like our 60% review meeting. What has been done today, you can just go ahead and, I'm not gonna go through the background of the project location. I think you all know where your treatment facility is located here in town. So just a quick background, and, in May of 23, we finished the preliminary engineering report and submitted that to the state. And we got comments on that. Last year, May 24, we proceeded with step 2, final design services, which was collecting field data. We've done some surveys and geotechnical investigations of the site. And at that, so we were also under contract to do some public outreach. And then things got put on pause a little bit while you were purchasing the water department. So we took a pause. December of last year, we came here in front of the select board and gave you we would like to look at some other alternatives for the biological process. We had that meeting and kind of came to the concept of proceeding with final design up into a 30% point. Then we would go for a bond vote because we'd have a better number. So here we are, we have amended the PER by looking at 3 biological treatment processes, and that's what I'm going to present today. And what my goal is today is to present those to you and to come away from this meeting with a direction of the biological treatment process for the final design of the facility. Okay, so what's the preferred technology to advance? Once we have that, we will finalize the PER, submit it to the state, to the town, and to the state, get concurrence, and then we'll be ready to advance into final design. So that's the goal for today. So go to the next slide. So I think I've already talked about this. We originally really only looked at one biological process. Previously, it was just to do a conventional activated sludge process that could be operated as, these acronyms are the Litthardt-Edinger, the LE process, an AO process, which is anaerobic oxic, and then an A2O, which is anaerobic anoxic oxic, and that's a conventional. And we opened it up to look at other process technologies so that we could have, how do we set up your plant to have more flexibility to meet future permit discharge limits, smaller footprint, lower construction costs, less power consumption, less chemical consumption, less complexity for the operators, and a process that would be more forgiving and reliable as the town grows with any kind of side stream loadings, which will enable the town to add growth. And that kind of growth that we're talking about is whether that's a brewery or it's restaurants, that kind of thing. So having more flexibility and being able to, I just want to, on that last bullet, really being able to set the town up and the treatment facility up to meet future discharge limits, which are coming to Woodstock's main wastewater treatment facility as a total phosphorus, and at some point in the future, a total ammonia nitrogen. Okay. So we can go ahead. So the three process alternatives we looked at, which are in the report, is the H2O process, which is, as I said before, anaerobic, anoxic, oxic. Okay. The sequencing batch reactor, which is the same technology that you have at South Woodstock, and anaerobic granular sludge, AGS. And I presented, or we had Aqua Aerobics come in and present on SBR versus AGS. You can go ahead. This slide I just brought up to show you those future permit limitations. And I just want to, these are not in the permit now. The state has not issued a revised or renewed permit at this point because the town has advanced into preliminary engineering and final design. So it's a good faith on their part. The town, they see the town advancing with upgrading this facility, and they are waiting until there's a design to be able to issue those permit limitations. So I just wanted you to be aware of that. What this does not have is a total ammonia nitrogen limit, which is we're starting to see, we're going to start seeing on the Connecticut River basin and across Vermont. What will happen is in the next permit, the next permit that is issued, there will be monitoring requirements. They need to collect data to know what the limits should be for that, for the plant. Go ahead. Biological processes. So, go ahead. So an H2O process has, it follows conventional activated sludge in the sense that you have different zones of aeration tanks. You'll have an anaerobic zone up front, which means absence of oxygen. So it's just mixed. And after that, you will have an anoxic zone, which is mixed as well. But what happens is you start to reintroduce a nitrate recycle into it to bring nitrogen-rich bacteria back into the process. You then go into an aerobic zone, which is where you put your air into. That's your compressors, they put air. This sets up the conditions for biological phosphorus removal and ammonia removal. And then it goes into your secondary clarifiers, and you have a return, RAS stands for return activated sludge, which comes back to the beginning of the plant, and that brings beneficial biology back to the beginning of the plant for those treatment processes to happen. The advantages of this system is that the anoxic zone allows for alkalinity recovery, reducing the need for any pH adjustment chemical. Those are usually sodium hydroxide or magnesium hydroxide. The internal nitrate recycle, the NERC line, increases your denitrification rate, which is needed for a total nitrogen removal to hit that limit in your permit. And your anaerobic zone is what is needed for what we call EBPR, enhanced biological phosphorus removal. It sets up the conditions for the bacteria to consume the phosphorus in the wastewater biologically. And that's going to help reduce the amount of chemical you need to then precipitate phosphorus out of solution. Disadvantages are that you have to have just the right conditions in that anaerobic zone for EBPR, enhanced biological phosphorus, to recur. Otherwise, you have to supplement with some kind of carbon source, which is like a citric acid, or you have to have the right volatile fatty acids being created in that anaerobic zone. So it is a little more temperamental. It's hard to maintain those conditions just right. It takes a good amount of instrumentation and automation to have this work. It does work. We're designing one right now in South Burlington. It's a very reliable process with the instrumentation and the controls that are put in. So it is work, it's a complicated process. So the next slide just shows kind of what that looks like, where that would be on the site plan. There's all that space. I don't know if that's north of the,
North is to the right.
north is the right, okay, north of the existing clarifiers. This is the largest footprint of the alternatives. It takes up the most tankage, because you have to have, each of the tankages are sized for those biological reactions to happen. So it takes up the most space.
Those two green circles are existing, they're green.
Yes.
Not blue. Normally the blue means the existing stuff, but they're being reused.
Yes, so we are refurbishing the existing clarifiers and that, and where you see the green dashed line would be future a location for a third clarifier if you needed it for a hydraulic increase. The light green, it's hard to see, would be future space for filtration, which is not going to be needed to start with. We anticipate a 0.8 milligram per liter phosphorus limit, which can be hit with the enhanced biological phosphorus removal and trimming with chemical. If the limitation were to drop below 0.5, that's when you really need to have some kind of tertiary treatment, which is a physical barrier like a cloth media or sand or that kind of reactive type of filter. And then the small little L on the end is the in green is the new UV disinfection. We can go to the next slide. So the construction costs for this process, you can see it's about, for the tankage and the equipment for the H2O process is about $5.7 million. A new process building would be recommended to house new blowers and any of the equipment associated with that process. We would do that all the way to the north of the facilities and have it built closer to that. And the reason for that is the existing space in the operations building is not usable for new equipment. It is below the flood elevation, and it would be trickier and more expensive to sequence the construction and keep the plant operational at the same time, which is a real concern. There's a cost associated with the secondary clarifiers, upgrading them and the clarifier house that's in between with pumps and access and RAS pumps and WAS pumps rehabilitation. I just want to, this cost that I'm showing here is for purposes of comparing it to other biological processes. This is not the full upgrade price. This is just the capital cost associated with this alternative, this biological. I just want to make sure that's clear. I am going to just pause here for a second. I also just want you to note that we tied these construction costs to the Engineering News Record Construction Cost Index. These are tied to the March of 2025. And later when I present full project costs, you'll see that I have escalated those to a projected construction date of when the project would go out to bid. And the other thing to note that these boy, I should have brought my glasses. The other thing to note is that these costs, they include a contingency for what we call BABA, which is Buy American, Build American, or Build American, Buy American. And that is the infrastructure law that was passed by the previous administration, that it was to jumpstart the economy. There are federal requirements to procure your raw materials and your equipment in the United States, and the compliance associated with that has driven costs up. So we have readjusted. So the reason you're seeing higher costs than previously is to account for that. Those are real costs that the contractor has to factor in, and the manufacturers have to factor into their price. And then
they have to basically get certification on every single piece of the plant. It used to be just the steel, the concrete, American Iron Steel. And now that's expanded to BABA, which is everything from the fire extinguisher to the luber to the primary clarifier. And we're dealing with it for the first time on Bartlett Bay, and it's exceptional. And
It's,
we're including it, it's there.
there are no pieces of equipment, electrical pieces of equipment that are made in the United States. I mean, that doesn't have a part that's not sourced from another country. It's the circuit boards, if it's the relays, contacts. So manufacturers are trying to figure out how to have a compliant piece of equipment, and it's driving the costs up. We've had some manufacturers tell us it's up to 40% added to the cost. These prices reflect the BABA, reflect that compliance. So that's what these prices are. And then the last thing I want to just note here, and this is consistent throughout, is that the contractor markup includes 20% for his overhead and profit. We used to carry 15%. And over the last 5 years or 7 years, we have seen that number is realistically more at 20%. MOB and DMOB around 8%. And that is, and that can vary versus like where the project is located. Like if you were up in the Northeast Kingdom, it probably would be more like 10%. This is Woodstock is situated at the crossroads of 89 and 91. So this would be probably a bit easier of a MOB and DMOB for them. And then bonds and insurance. And we carried 2% for that. We have found that projects that are within a floodplain have to carry a certain level of insurance from their insurance companies. That is quite onerous for them. So these are real costs. We can move on. So the second technology is aerobic granular sedge. I'm not going to go through all this because we had this whole presentation with aqua aerobics with you. But basically, this is a dense sludge that is created at a much higher mixed liquor suspended solids. And I'm just going to go to reiterate for the record, the advantages of this is that all the treatment happens within this singular granular, and you don't need all the separate tanks. You don't need to have a tank that has no oxygen, and you don't need the tank that has the recycle come back to it, and you don't need the tanks that have the aeration. It all happens in one tank in a batch type fashion. So that eliminates large tanks, it eliminates the clarifiers, it reduces, because all of this is happening biologically inside the granular, you have reduced chemical costs. It can handle high strength supernatants off of the holding tanks and off of the dewatering equipment. And it has a smaller footprint. This process would come with a guaranteed manufacturer's guarantee, process guarantee, and aftermarket service. We listed as the disadvantage that it's an emerging technology. It is not. I don't think we see it as an emerging technology so much anymore. There are plants that are being commissioned all around the country and all across Europe. And so it really is starting to take off. So I don't actually see that as a disadvantage. So again, on the site, and whether we go with round tanks or square tanks, that can be a discussion during design of what is more cost effective, but this would happen at the northern end of the site. What's not shown on here is a process building that would also be on the northern end of the site to house any pumps or air compressors that need to be in there. So basically, it's a lot smaller of a footprint, and it gives you, after the clarifiers are demolished and the existing aeration tanks are demolished, it gives you a lot of room on the site for future expansion of the plant, if that is where the town chooses. Go to the next slide. So the capital costs associated with this technology is it needs to be a pre-equalization tank that just kind of levels up the flow before it hits the tanks for the AGS. That's about $500,000. The AGS process including all the concrete for the tanks, equipment, civil site work, electrical work, about 4.1 million. That process building, same for all three examples, is around $1 million. So with a subtotal for construction costs at 5.6, contractor markup, this is about a 7.37 MGD alternative. Go to the next one. SBRs, same technology you have down at the South Woodstock facility. Again, it's a small footprint because it's all in one tank. And it's more of a conventional activated sludge because it's happening. It's the same steps that are happening in the first alternative where you have an anaerobic time, you have an anoxic time, you have an aeration time, you have settling. It's just all happening in one tank. Advantages of this is that it's standardization for the operators. They know this, they know the facility at South Woodstock would be the same kind of operation. They're familiar with it. It's there's a process guarantee and aftermarket service. Aquarobics has a very good track record with that. It eliminates the clarifiers, gives you space on the site for future expansion because it kept it very modular, just like AGS. And you know, that batch process, like I said, it takes place in one tank. And one of the good advantages of this, it's the same with AGS, is that you can vary the cycles to account for variations in incoming flow, variations of strength if it needs to be aerated for a little longer because it's coming in high in nitrogen or high in ammonia, or if we have wet weather, it can go into storm mode. The disadvantages of the sequencing batch reactor is that it is limited in its biological phosphorus removal capabilities and will require of all three the most chemical addition to achieve phosphorus removal. We'll go to the next slide. And again, on site, I'm showing three. I think in the report we're calling for 2 SBRs with a pre-equalization tank, but that just shows you what how those would lay out on the site. A little bit larger footprint. The cost estimate that I'm about to share with you is for it's for 2 tanks, not 3. Okay. We'll go to the next. And then the cost estimate for this, that pre-equalization basin is a little bit more than it would be for AGS because it needs to be a little bit larger for the cycles, the batch cycles. The SBR process, all the concrete equipment, civil site work and electrical, about 4.2 million. Again, the process building around $1 million for a subtotal construction cost of 5.9. Contractor markup, this is about a 7.7 MGD alternative. So we can go to the next slide. And this is where what I'm not presenting to you is all of how the sausage making of how we determine O&M costs. But to do a present worth analysis, the first thing we do is we look at what is the connected horsepower of all the equipment, and we compare it across all the alternatives at the same flow rate. Okay, so it's connected horsepower that's to factor into the O&M cost, and that's all in the report. That's all in the report. It's chemical usage. How much chemical is associated with each different alternative? Like I said, SBR is going to have the most chemical consumption because it can't do biological phosphorus removal as well as the others. And then man hours. Which one's going to be more operator hands-on than the others? And so the top line is the capital construction cost that I just presented, 11.7, 7.4, 7.7. The next line is the annual estimation of O&M costs for each of those alternatives. And we then plug that into a formula to calculate present worth, which is a 20-year evaluation, looking at it over 20 years and with a depreciation. And you'll see that the present worth alternative two is the most favorable over that 20-year lifespan. So. And this is all in the report, and it's a little bit more of a broken out of like O&M costs if you really want to get into the sausage making. But I just wanted to get this up. So alternative two, AGS has the lowest present worth. Alternative three is just behind it. And alternative one, the more conventional activated sludge process is the highest. And it's really the highest because of the amount of tankage that is being, that is involved with that process. All right, so the next, it's hard to see this, it is in our report, but we kind of went through just some non-economic kind of comparisons with each of these.
I'm gonna turn my screen around for the board. Are you guys,
Can you see that?
No. I'm on this.
well, you can just.
Okay.
For this slide, please.
Okay. So basically, we took each biological process and we kind of ranked them and gave them a score on how they would do on a total nitrogen limit. Okay, the first column. And basically, all three are gonna be able to hit a total nitrogen limit that comes in your permit, because, you know, the denitrification capabilities are there in the tankage. You would build it sized appropriately for denitrification to hit that amount, to hit that total nitrogen limit. The phosphorus limit, I think I talked about this before. The SBR got a 0 rating because it's not going to have the conditions available to do enhanced biological phosphorus removal. A2O process would do better at that. It got a score of 2, and the AGS got a score of 3 because it all of that enhanced biological phosphorus removal happens within the granulars without chemical addition. So it's gonna do the best. It's gonna do the best without chemical. Biological tankage, again, the A2O process at the top is the largest, so that got the lowest score. The SBR is the second largest, I got a 2, and AGS got a 3. This is the small footprint. Reliability. We gave the AGS a score of 3 out of 3 because it significantly improves the reliability of your plant. It is going to have the most flexibility and able to treat any influent that's being thrown at it. Whether that is a process upset coming down the line from a user, whether it's high strength decant coming off of the sludge holding tanks, it is going to be able to react better to those kinds of upsets. And we scored the A2O process and SBR process the same for that, for reliability. Complexity, we gave SBR the best rank, the best score here because we're familiar with the process. You have this at yourself with stock, but that's pretty much the only reason we gave it the best score of complexity. I honestly would probably give A2O the worst score here because it is more things to operate. There is more things to have to work on, repair, and maintain, you know, and you got all of those have to be running perfectly to be able to hit, you know, EDPR. All of them have to be. You can add computerized controls, you can add automation, and that will help with that. But that is like the most complex of the three. AGS is going to do it in the granulars. It's going to take a lot of that out of the equation for you. There will be things to maintain like blowers, pumps, but it will be the least amount. It will not be as bad, I think, as the A2O process. So I would have scored that differently, but we didn't think we could get an AGS a perfect score across the board. Chemical consumption, I've talked about this. The SBR is ranked the worst because they are going to require a higher amount of chemical to be able to hit the phosphorus limit. And AGS will be able, will get you very close to the phosphorus limit that then would just need maybe a trim to actually get. Point. It may not be needed. I think the manufacturers have said they can get below a 1 milligram per liter, but I think you'll have that chemical as a backup, just to trim, to have it, okay? And, H2O should be able to get fairly low. It would have this, it would land in the middle between, the SBR process and the AGS. You can go to the next. So, one other thing we took a look at, for this PER is we opened it up for some dewatering alternatives. And with, you currently contract dewater right now, and the thought is that the price to hire Paul Senasac to come and dewater your sludge is going up and up and up, and he's the only game in the state of Vermont. So you are beholden to whatever he charges you, and his prices have been good. So I took a look at what could we do at the plant? What could we do and what would be the payback? So I talking with Tim, we looked at a few different alternatives. We came up with a rotary press, which is I can get into all the mechanics of it. Okay, rotary press is it operates at a very low RPM, and it basically you're just squeezing. Okay, it applies pressure, it rotates very slowly, and it's squeezing the water out of the sludge. Okay, very low horsepower. There's a few of these facilities in the state of Vermont. Town of Richmond loves theirs. Brattleboro has one, they love theirs. These are very, the guys in Richmond turn it on, they go home for this night, they come back the next morning. It's a very reliable piece of equipment. The next slide is just what that cost would be. And we were looking at retrofitting one of the bays of the maintenance garage. Not a new building, but just could we put it in there and just do some minor improvements to the building, HVAC, things like that, to be able to add dewatering. So a total cost, you'd have to add polymer. You add polymer to sludge to help it kind of come together. So a total cost, I'm just gonna go to the bottom line, it's about 1.8 for a dewatering alternative. Second alternative is the centrifuge, and the principle of how this works is the centrifuge spins at a high RPM, and basically forces the water out. You know, if you think of those amusement rides where you're spinning around and it forces you to the outside, a centrifuge is forcing the water to the outside, spins at a very, very high RPM. There are many centrifuges around the state of Vermont. People use them, the facilities use them quite reliably. They're a little bit more hands-on, and, you know, a lot of operators don't feel terribly comfortable with a piece of machinery like this spinning at tens of thousands of RPM on its own. But it is a reliable technology. So we took a look at that. Go to the next slide. The total cost of that is about a $1.6 million investment. Okay, so the third alternative is a screw press. And basically this is a pressing technology. And if you think about it, it's the screw is just forcing the sludge to an area of compaction. So it is squeezing the water out too. The screw just presses it to the end. These are very reliable. They have them all over New England. Many people love these. These are, again, one that people walk away from. Turn it on, they set up, come back at the end of the day or the next day. They operate very independently. And the price of a screw press is about 1.5. So if we go to the next slide, just a comparison of them all. Again, so the first line is that capital cost of the equipment. The second line is the O&M, and as you can see, a rotary press is a lot less expensive in annual operation and maintenance, and it's due to the fact that it's like a half horsepower motor. It's not, it does not require the same kind of motors as the centrifuge, which usually has two motors, has for the main scroll and the back scroll, usually around 50 to 75 horsepower, each of those motors. So that's the big difference there. The screw press also has a pretty big motor to drive the screw. Polymer cost is going to be about the same across the board. So it really is the electricity that is driving the O&M cost. I think what we also argued that the man hours at a rotary press would be less than they would be at a centrifuge because you can walk away from them. So with the present worth over 20 years, you can see that, alternatives 1, the rotary press, and alternative 3, they're about the same, 2.5, 2.5, it's about the same. So it's really, that's what we came up with, some dewatering alternatives. So the next thing I wanted to do was just do a simple payback. Like what would this mean for the town and paying back? Like how long would it take? And this is hard to read. But basically what we took was the amount of sludge that you're dewatering right now. And what is the unit? We came up with a unit cost to dewater that sludge right now. And then we factored into the price. And this is based on real numbers from Paul Senesac. And then we factored in what it cost him to mobilize and demobilize, and then what it was so that there's an annual dewatering cost. This doesn't even account for disposal costs. This is just to dewater. And we escalated those prices over the years to account for inflation. Because we saw a real jump in Paul Senesac's cost. So we used that as the basis and we escalated each year. And by doing that, we came up with about a 9 to 10 year payback, depending on which alternative is chosen. And there still is a cost to dispose of your sludge. All 3 of these alternatives would result in roughly the same amount of cake solids, which could be improved with the right type of polymer. So I don't think one is going to have a drier sludge than the other. You could get to the point where you actually pilot it on your sludge, depending on what kind of biological process you use to dewatering equipment can be pilot. But anyway, I just wanted to do a payback. But when would this pay itself back? This gets it out of the hands of a contractor. I'm gonna. So I want to talk about total project costs and yeah. I carried the lowest biological process in here. This total project cost under the first column, this is the current tag to the engineering news record construction cost index right now. I carried the AGS because it was the lowest one. Obviously, this would go up if a different biological process was chosen. The first line is your screen and new headworks building, grit removal, the intermediate lift pumps. These are all of the things that have been identified in the preliminary engineering report that need to be rehabilitated to meet your wastewater needs for the next 10, 20 years. The prices have gone up, as I mentioned before, because we adjusted them for FABA compliance and we adjusted them for tariffs. We don't know what tariffs are going to do, but anything that is not concrete or gravel or PVC pipe, which is made domestically, we added a 20% to it. So these costs, it might seem alarming, but these costs have some serious contingency built into them, which we think could be real or may not be real. So this is what the total project would, if we get down to, I think it's 20, current cost at 20.8. We carried a 30% contingency, and you carry 30% contingency throughout design. And the reason for that is because you might find things during design that need to be added to the project. It is a buffer. A real example I want to share with you is the city of South Burlington. We're in design. They had a December storm where they lost the solids in their clarifiers. They had both of them. They had two. We were just going to rebuild two of them. And they saw a peak flow that they have not ever registered at the plant. And it forced us into building a third clarifier for them. That is something that wasn't identified in the preliminary engineering report, and that's why you carry contingency. So that number is, that's what 30%, that number drops at heading into construction, you drop that number to 5%. So right now, contingency, that's like $6.2 million that may not be realized. So the numbers look high, but I want you to understand that there's some padding in there for unknowns. You carry 5% going into construction for the contractor for things that come up. It is an example that it's not going to be applicable to Woodstock, but if the whole site, if they found ledge, 10 feet down, like that's why you carry that kind of contingency at 5% going into construction. So we then project the cost up to a projected bid date, September 26th, which is actually quite aggressive. We generally look at about 18 months for a design and approval from the state to be able to have approval to advertise for bid. So that could be a little later in fourth quarter 2026. So with all said and done, we're looking at a total project cost at the time of bid at about $32 million. And again, there is a lot of contingency put into that, $6 million of contingency, and there is contingency to allow for tariffs and unknowns of the market right now.
Can I ask a quick question on the
Yes.
price?
Yep.
So if you take out the process, I know you use AGS here, those other costs. Is there any way for those to decrease, or are those built into what the cost of just doing a new plant on that site?
I think if I understand your question, you're asking if these costs are associated with rehabilitation.
Yeah.
Of your site.
Okay, yeah.
Not a new plant.
Yeah.
Rehabilitation. The things that are new are the screening and headworks and grit removal. UV is new. And the AGS system is new.
Okay.
We did carry dewatering facilities. There are parts of this project that could be pared down if need be. Is there a question?
Kristen, I was just wondering, I assume since you put the returns chart for the dewatering machines at 20 years, is 20 years like when they would all need to be, when each of those models, that's about their lifespan, when they would need to be replaced, or would it be longer than that? I'm only asking, we did a 30-year bond for the water company, and I'm wondering for both the wastewater treatment system and some of the components that we talked about for dewatering, what the kind of standard lifespan would be for some of these components.
Certainly, dewatering equipment can last longer than 20 years. I'll just give you a case in Richmond. their facility is beyond 20 years and their dewatering equipment lasted they needed to have some replacement parts, but it's not replacing the whole dewatering unit. You know, they needed to replace a couple, they're called channels on the piece of equipment, get a new, they needed a new control panel. As you can imagine, control panels and electronics tend to become obsolete after so many years. But those aren't full replacements. Those are just components of it that need to be upgraded. In about 20 years, but 20-25 years, with good maintenance, it could go longer. With good, preventative maintenance, certainly could go longer. I mean, you have stuff at your facility that is from the 70s.
So I have a question. So after we get this built, the state's gonna turn around and tell us we have to upgrade it.
In what sense?
You talked about, discharge and,
The ammonia, the
ammonia
future.
and.
No,
So this upgrade would allow you to hit future discharge limitations. It would set you up to meet those. You would not need to upgrade. Your plant as stands will not meet those limitations.
So for 20 years, let's say that's the lifespan, we don't have to worry about upgrades from the state.
That would be correct unless you grow hydraulically. If you're adding users that are beyond the permitted capacity of your plant.
then you'd add a little more tankage like
Yeah.
we showed, right?
Yeah,
You add to the system.
but that would, for us, that would be a good thing, because we'd have
Right, you
more
have a
taxpayers.
more user base, more tax base.
So then what is the capacity that this is designed for?
This is designed for
450,000
450,000.
And how many gallons do we average now?
I think we came up with, you could add about 500 units.
Yeah.
Units. I wish I had that I had a nice analysis.
Yeah.
We're averaging about
Yeah.
130 to 40 without rain right now.
So you have to save about 20% of your capacity. Like when you start bumping up over 80% of your capacity for 90 consecutive days, the state's like, what's your plan? You know, they want to look for, what is your plan? You're bumping up against your permitted capacity. So, that differential between 80% and where you are now is about 500 units. So that doesn't, I mean, you're not gonna go over capacity, but that's that differential. I don't know if we have any more slides.
Push the 9. Just push the 9. Or the 3.
So,
3 over there. That's the page down button. There you go.
go one more. Hit it one more time.
So this just took off $1 million, by the way.
So project schedule, originally, inside the box was our original schedule, and this is what we're proposing is that we finish up this PER amendment and move forward with a recommended project that we finalize the report, we give it to the state, and we get the state on board, and that we advance into final design. So what you see is basis of design and 30% complete. That would be this summer and, third and fourth quarter. We've shown here in bond vote in November. That doesn't have to happen. That doesn't have to happen this year. It doesn't have to happen in March of next year. I think what I'd like to leave you with is I'd like to see you advance into design so you have a shovel-ready project ready to go from when the town's ready. And I want to stress, your plant doing nothing really isn't an option. Your plant has, we have stated what the condition of the plant is. The state has seen that condition report on the plant. They they believe you are acting in faith to upgrade your facility in some capacity, some, not hydraulic capacity, but in some form or fashion, so that you do not have permit violations. So what I would like to encourage the town to do is to advance the project into final design. We will have a better number for you as we go through that design. We can reduce that 30% contingency, you know, as we've gotten through design, and then you'll have a solid number to go for bond. We're not saying the town is gonna spend 32 million today, or even in the next 5 years. The repayment on the bonds don't happen until 5 years after construction, 5
5 years after design, 2 years after construction,
5 years.
so. If it went to bond this fall and got built in the next, we need 18 months to design, 2 years to construct, 2 more years until the repayment of the loan starts is 2030 as soon as it could be. I would add, you know, Bolton Valley is a project Kirsten and I cranked out last year for certain reasons. Got done by June, and then they needed to find more funding, Northern Borders, and they haven't gone out to bid yet. So that's been 12 months, it's been 11 months, and they made the choice when they have to build it. You know, Lindsay up there at Bolton Valley wants to expand, and she has great plans, and she absolutely needs to do
She
this
can't
plan.
expand, she cannot expand her development on the mountain, which is the revenue she needs unless plant is upgraded. So she's constrained by that. The other thing that advancing into final design does for the town is, and putting off the bond vote, is there might be more favorable funding. I know things are uncertain right now. I know they cut the congressional directed spending. We did reapply for it. Things might change at the federal level where those funds would become available again. There could be other programs that could be looked at. I think getting yourself on the state list for the Clean Water SRF would be a smart thing. So you show that you have a project that you're committing to, and you get a higher priority, which is more beneficial for you when they start doling out the funds that the state has. The cost of waiting the project will get more expensive the more you wait. You won't, if something were to fail at the plant, you would be paying for an emergency repair, which is a Band-Aid, and then you'd still have to pay for an upgrade. And I'm gonna give you an example of another town we're working with in Littleton, New Hampshire, has clarifiers that are about to fail and has to do an emergency repair to them. And the clarifiers are undersized, don't meet the state guidelines. They will have to mothball those clarifiers and build new ones with their upgrade. So that is money wasted. $1 million wasted. And I fear that if there's no action, I mean, we're already talking about not having construction until, you know, being done in 29. I'm not sure the plant, you're getting at the edge of the reliability of the existing. Delaying will only cost you more money, and there'll be more competition for those federal dollars as well. There's a lot of uncertainty in the market. There's a lot of uncertainty with Congress and the funding. There are other avenues that they're trying to steer states into, which are, it's called the Whisper program. It's instead of the Clean Water SRF. We're gonna do a little bit more research into that. It does require some matching grants. It may not be as favorable as the Clean Water SRF program, but we'll take a look at that. And you know, there could be other, if there's an economic incentive to this project, we could look at a Northern Borders grant for the town. They like to see some kind of growth happen with it. Like you are providing work, you're providing jobs. This expansion would benefit the town economically. So there are other avenues for us to take a look at.
Kristen, sorry, do you mean like in terms of commercial development or residential development or both?
Both.
Okay, thanks.
It doesn't have to be both. It can be and or. Just.
Yeah, I mean, I think we want both.
But there are other engines, there are other funding mechanisms out there.
We put off a vote, I think we need to warn a public meeting. Maybe put this off till 29th.
Put what, sorry, like the decision,
We can't vote anyway. It wasn't, it's not warned to vote, is it?
Right,
no,
no,
but what are you asking to vote on?
the
Sorry.
decision to go to 90% design.
It's not warned.
So, what I asked for is direction on biological process, so that I can finish the preliminary engineering report and submit it to the state. And so that is, are we gonna go the A2O path, AGS path, or SBR path? So that's what I would like to leave with.
Sounds like you recommend AGS.
That is the engineer's recommendation. And it is also based on what I'm hearing from the operators.
Yeah, I guess we can't vote on it, so. We can suggest it.
Can I ask, would waiting to the 29th delay you at all? I
No.
mean, I know you're going away for a bit too,
That's,
so.
it's fine. This does not delay.
Then let's
If the
put this
board
on the agenda for the
just wants
29th.
to discuss, maybe talk
Yeah.
about this.
Yeah, and plus, I think, just to be upfront about it with everybody, we put it on a public vote.
Not
Just-
public voting, but
No, I know.
vote in
Who
public.
wants that?
Just clarify.
So then we vote on what biological process to use for the final.
Yes,
And then with that is the idea of adding dewatering upgrade to it. And again, it could be something that's designed but not implemented. That could be an option. And we could look into phasing of this work as well. I think you're gonna get the most favorable price if the project goes out for one contract. But that is also an option. We're doing that town of Littleton is, they're phasing their project. Doing the headworks first. Well, during that emergency clarifier repair, then doing the headworks, and then upgrading their biological process after.
that costs more money.
It does. It does. You're paying for mobilization 3 times. Prices are gonna go up. Of those projects. For sure.
So the contractor that gets the job, we're gonna pay for him to mobilize and demobilize.
Yep, just
And
one.
then he's gonna go to the next job and charge them to mobilize and demobilize. So if he has another job to go through, he shouldn't charge us for demobilizing. Just throwing that out.
And I'd also like to say, there are we're seeing, projects are coming in really high, higher than communities can afford. Like, I mean, we understand this is a lot. This is a big project. And we're seeing other communities investigate or look at what's called a CMAR approach, which is a construction manager at risk. What that does is it brings in a contractor kind of early on in design, and they give you a guaranteed price that will not change. And so that's locking in a contractor kind of early on. And the discussions, I know that this is an approach that, say, Burlington's using. I don't know if you saw the jaw-dropping project that they're proposing. Because it's so high, having that kind of construction manager at the beginning with a guaranteed price going into construction will help the city say, this is what it's gonna cost, we know what it's costing, and then they're not open, then they don't have to worry about bids coming in too high. But it also takes out the competitive nature of bidding So it could go, it could have a negative effect as well. But that is an avenue that we're starting to see around the state and around New England. They do this much more in the south than they do up here. For sure.
Yeah, the CM can also push back on the designer though.
Yeah.
As well, that's what, they can say, well, there's only $2 million, so go redesign it 3 times and make the doorknobs cheaper and so forth. So there are pros and cons to it for sure,
Yeah.
but it is another approach.
It is another approach.
Yeah.
Is there anything the board would want from Bill Tanner in the next 2 weeks for more information on a process that he could provide?
I don't think, I'm fine with what I've got. I don't know about anyone else.
We open it up to see if anyone else has questions.
Been reading. The only thing I'm gonna say is, this can's been kicked down the road since I did. Been here 18 years, 19 and. Okay. I've watched this happen 4 times. In 2023, we had a price tag of, what was it, 13 to 23 million dollars. The original design. What was wrong? with the original design? In 23, we said, no, we're buying water department, we're gonna take that off, that's fine. Understandable why we did it. It was a vote for the school, we were worried about that, we're buying the water department, worried about that. We now see we went from 23 million to 30 million. Longer we wait. We all know, like Greg is a businessman, knows labor costs don't go down, they go up.
The equipment prices won't
Equipment,
go down.
everything goes up. So I'm not saying we shouldn't wait, no, agree, but it's a big $30 million, lot of money. But this is because of, it's been kicked down this road so many times. Nobody wanted to do it. Well, we'll wait, we can do it later. No board wanted to deal with it. We're getting to the point where the state's gonna step in like they did in South Woodstock. We got told in South Woodstock, you need to bond it, you need to get this started, or we're going to start fining you by the day. Push came to shove, there was a engineering firm that no longer works for us. Proven number, $2.6 million, we bonded, 0.6 million. And that project finished at 4.3, I believe. Because when Old Tanner was brought in, after the other engineer firm, was booted, first words out of their mouth was, we're not doing this, there's no way to do this for less than $3.2 million.
Site was
It was
challenging,
Yeah,
to say the least.
but it was, as soon as Old Tanner saw what we had and saw the original engineering thing, they went, there's no way that number's gonna work. We couldn't go back out for another bond, we knew we did. The state, as she said, is looking favorable at us for their putting off the permit because we are looking into upgrading. They know we are. If we don't do something next 3 to 5 years, they're gonna step in. Within 3 years, we're gonna have the permit, I guarantee you. We're not gonna be able to meet that. The first year they give you, okay, let you try to do it. If you can't do it within a year, then they're gonna bring compliance in. If we're still not meeting it, that's where the fines. And they can really get ugly and really start. As I said, I'm not a town, I'm not a member, I'm not a taxpayer. I don't have, I understand it's a big pill to swallow. But the more we put it off, that bill's gonna keep getting bigger.
So in order to meet the phosphorus limit with the existing facilities, it's gonna require some kind of chemical feed and storage facilities. The chemical can't sit outside. And it's going to incur a higher cost. It's going to incur more chemical because there is no biological phosphorus removal happening. Because the existing aeration tanks can't operate in an anoxic fashion. So you're just gonna have to throw chemical at getting phosphorus out. There's no filtration. It's just purely gonna have to be addition. And so that's gonna be very expensive. I mean, That's how, that is what it is. If there were a problem with, steel tanks, the divider walls in that existing aeration tank and one of them were to fail. I think you guys have seen the plant. Seen that?
No, but I've seen the picture.
What could happen is, all the two separate trains, all the flow would mix into each other, solids could settle out in that one place where there's no aeration, and it could go septic, meaning anaerobic, and that could kill the biology that's in the, aeration tanks. And that could, I'm just gonna use words like could, 'cause we don't know, we don't even wanna test it, it could make you not meet permit. That could deteriorate the biology in the aeration tanks to the point where they can't make permit biological, like you get the VOD down or the, or your nitrogen down. The plant as it is now will never meet a total ammonia nitrogen limit. Will never meet that the way it is now.
And I want to clarify one thing, because I think the way the permit is used in this situation is so much different than I think what we're used to thinking. Like you're used to thinking you go get a building permit and you build to that.
Yeah,
But here they give you a permit and say, you have to be meeting this level, you have to be meeting that level. And so at some point, if we don't move forward, the state issues a permit and we're immediately in violation of that permit.
and what will happen is they'll give you a compliance schedule.
Mhm.
They will dictate you shall be in design for this by end of this and finished design, you will be under construction by this date. That's a little heavy handed. The state would want to work with you in order to make that compliance schedule, but there'll become a point where every day that's violating the permit will become, administrative action.
Susan, just for your analogy, it's like you get the permit, that's your permission to build a home, but you're building the home to codes. And our permit is essentially those codes.
Someone had a great analogy the other day.
Well, if you're the DMV, your car's not passing, this car's not passing inspection. But it is interesting, I'm a structural engineer, you don't know that, but the codes. These permits, they change, they add the add limits and add limits and add limits. And I was like, well, that is a little different than the international building code, but it's honestly not, the wind design loading chapter when I started was a couple of pages and now it's like 122 pages, how to calculate wind pressure on every different little surface, so. And of course, you don't have to go back and change, the Empire State Building to meet today's codes, to meet the new code when it rolls out, that would be the difference here. But it is what it is, the environmental regulations are getting more stringent, and it used to be, phosphorus, I guess.
It used to be, well, it's phosphorus in the Lake Champlain basin, but they are starting to impose phosphorus limitations on this side of the Green Mountains, anything that drains to Winnipesaukee or to the Connecticut River. The Connecticut or the Long Island Sound drainage basin has a nitrogen limit. You have a nitrogen limit. Well, it's not written into the permit yet, but as soon as the permit is issued, it will be written into the permit. That is different from a total ammonia limit, which they're gonna start requesting data on so that they can have factual information on the receiving stream. They have to meet, so the guidance is, what you're trying to meet is the water quality standards of the state of Vermont. So they're looking at what your effluent is and how that impacts the receiving stream. And that is the governing that's the governing code, the water quality standard. So.
Questions, comments?
I'll go for one more. You were talking about a public vote for the process. Does that mean in front of public or having the public vote?
In
No,
front
that,
of.
that means,
Just in front of, okay.
Yeah.
that means that's voting.
Fair enough. The sake of, it's a pretty confusing situation. Yeah, it is.
No, it's just for us. Okay,
All right,
thank you.
you're welcome. If you have any questions along the way, you can, email me. I think you all have my
Sure.
email, or you can get it through Eric. And I'm happy to answer any questions. I'm going to celebrate my daughter's graduation with a trip to Japan
Lovely.
next week. So, I will be out of the country for a couple of weeks, but,
Or-
Paul will text me with the
Yeah.
decision on the 21st.
Yeah, should anyone come down for that? Should,
I think I'll, if the board has questions,
Yeah.
I think they should be okay, but if not,
Okay.
okay, no.
yeah,
Yeah, and Paul and John and, Amy can come down. Amy is, I think you've met Amy
Yes,
before.
yeah.
She's my biological treatment right hand. She can answer any like, confusing questions about the process if you need that. And, Paul,
I just want to circle back. The first thing Kirsten started off with was we're not spending $30 million right now. We just strongly recommend that you move forward with the design to kind of keep the permit in place and just the shovel ready and all that stuff. And I go back to Bolton Valley, we cranked to get that done by the end of fiscal year 2024, and then they needed to find more funding. So you're not alone, but they have a
I
design that's
hold my
ready to
breath
go.
that that plant doesn't fail on them.
So you're not alone. This is kind of normal-ish, but
Not many communities have that kind of money.
Yeah.
It's really difficult.
Bake sales aren't gonna do it.
Bake sales aren't gonna do it. I mean, just an example, and I'm not recommending like for these guys, for your facility, but like Richmond's considering becoming more of a septic receiving facility to generate revenue. There's definitely facilities that see that as a way to increase their revenue to take that burden off of the taxpayers, or not the taxpayers, the users. So, and we can, we started to look into the rate analysis, and we can advise you more on ways to shoulder the burden of the project. So. All right,
Thank you very much.
thank you so much. Thank you for your time.
So just two quick things. One, Green Mountain. So, I shared with the chair and vice chair a while ago, and I know Susan shared with the rest of the board. Is this Green Mountain's looking to move the poles, they just need to sign off on a permit to have the select board approve it.
Yeah, I've seen that.
Yeah.
Needs to happen.
Yeah, I think so.
So I just, it's a permit. It's an action on your part to approve the sign off on the permits.
So I move we approve the Green Mountain permit to move pole 95-2 away from the river edge. And the other actions described in the notification of pole, wire, and underground located.
There's a second.
Second.
All those in favor?
Aye. Aye.
Now your usual license.
Oh, yes.
So last one is 506 on the river, looking for outdoor consumption. I know Susan will do the normal thing, but also just make sure that they're following the guidelines of making sure it's barricaded or have a space between with alcohol allowed. Would be my only other recommendation.
Okay. So I move we approve the outdoor consumption permit for 506 based on two assumptions, one assumption, one condition, the assumption that the state is reviewing the permit since they don't give out enough information to do that anymore, and a condition that they comply with all of our fencing and other requirements for outdoor consumption of alcohol.
There's a second.
I'll second.
All those in favor?
Aye.
Okay, we no need to go into executive session.
No.
Move
No.
adjourned.
Second,
A second.
all those in favor?
Aye. Aye.
Eric, do you want to sign this?